Hello and welcome to Spreadsheet 2. This is information processing 2080. We are looking at topic 3.3, using functions to calculate interest rates, monthly payments, and present values, such as the payment function. So these are all in the financing section. So let's come to our sample spreadsheet and look at our financial functions. So let's say we want to insert a function. It'll be in the financial category. We can look at accrued interest at the time of maturity. The specific payment, or the function that they had, is the PMT, periodic payment for an annuity investment. We can pick any of these here. This will ask us for our rate. So let's say we have 3.5% interest in the year. This should be 0.035. And we do 1 per year. We start at $100. We see here in the end it's $103.50. That would be our payment if we were doing it in the course of 1 year. Now, we could also use the future value and whether it's the end or the beginning. So that present value of $100 with a 3.5% interest rate paid once says we'd have to pay $103.50. But let's say at the end of that period, we get it down to $50. That's our future value, right? This is showing us that we have to have a payment of negative $153. That's because we have to be careful with our present and future values. The present and future values should be negative if we're talking about paying off a debt. So we'd have to pay $153.50 to pay it off here. We can also do the end of the beginning. But all of these payments are based on our compound interest formula. Quickly flipping over to a whiteboard. So the present value of any compound interest payment is the original value times 1 plus, sorry, these are tall and skinny. This is still configured for the pad I have at work. It's the interest over the number of payments, or the number of months in a year, number of interest calculations in a year. And then up here we have the total number of payments. So if our initial amount is $100, and we have 0.35% interest calculated once per year and one payment, that's our $103.50. So it's not too bad to use this equation if you're looking for P. If you're looking for N, or the lowercase n here, that gets trickier. But we have other functions for that too. You might have noticed the N per, the number of payment periods for an investment. So let's say we have our same 3.5% interest rate. We are paying $100 a month. And we currently have, let's say it's a small mortgage, $50,000 left. And actually, I'm going to go back and change that to $1,000 if we're talking about a mortgage here. If you can find a $100 a month mortgage for a $50,000 amount, let me know. And then the future value, let's say we pay it off down to 0. We notice in this fill in the blank that future value is square brackets. That means it's optional. So it will assume 0 if we don't put anything in. But this is telling us our number of periods is about 30. What's that? Negative 29. If we're talking about it as a debt, right, that negative is negative 50,000. So that doesn't work. Yeah, we have to bring it from 50,000 to 0. So we're losing that negative 29 each time. If we are looking to solve for other variables, we can look at PV for the present value of an annuity investment. So let's say we have that same 3.5% interest rate over 10 years. We're adding $100 a year. What is our future value? Well, again, we have to be careful with whether we're using positives or negatives here because it assumes some are debts and some are nots. But yes, it is $831.66 is what we have here. So if we change this to a negative, we find that yes, it's worth $831.66 at the end of this period. This does have all the functions needed to take that formula and solve for any of the variables that we had in it. So we can solve for our interest rate on the annuity of an investment. We could find discounted prices at a security. We could look at how much payment we made on the principal of an investment. So how much of the balance is the principal? How much is interest? There's a lot of different different formulas we can use here. Those are the key ones. But yes, you could find the payment on the interest. You could find effective interest rates, which is useful. And you could find the future value of an annuity investment. So if we're looking for the P, we can use this FV function instead. So we have quite a few of these different functions to pick from.